Coming to operators, normally operators in the sense like addition, subtraction, multiplication, division, like that we have some operators. Okay, but other than that, there are other different kinds of operators also. I would like to discuss on all that. So in operators, like we have arithmetic operators. These are common, right? So arithmetic operators. So which is basically nothing but addition, subtraction, division, all that. Okay, and coming to the next one, comparison. So comparison operators are basically nothing but less than, greater than, like that. Okay, and next thing is assignment operators. Assignment operators. So assignment operators are nothing but, so once you do the comparison or once you do the arithmetic operation, and then along with that other operators, you will also assign that value to the variable. Okay, I'll show you that in detail. And then logical operators, and next thing is bitwise operators. Logical is basically nothing but and or not. Okay, so bitwise is XOR. Okay, so like that. And coming to the next one, membership operators, and then finally identity. Okay, so these are all the different kinds of operators that we have in Python. Okay, so coming to the first one, so arithmetic operators. So arithmetic operators, as I told you, we have so different kinds of operators. Like, so we know normally addition, subtraction, right? Subtraction, and we have multiplication, division, and there is one more thing called modulus. Okay, so modulus is basically going to do find the quotient. Okay, so when you do the division, so you'll have quotient and remainder, right? So the division output and the multiplication output will be different. Okay, say for I'll come to that. Okay, so the next thing, exponent. Okay, power basically, and then floor division. We call this is floor division. Okay, I'll tell you what is floor division and all. Okay, so okay, so coming to the first one, so we know addition and all, right? So we already did it. So simply say a is equal to 10, a is equal to 20, so b is equal to some 10. Okay, so a plus b, basically we are using the addition operator. Okay, and similarly, so I'll take print a plus b and print a minus b. Okay, so addition, subtraction, division, till that I'll tell you. So a minus b and a into b, so all that. Okay, so addition, subtraction, and multiplication. And then when you are doing division, so 20 divided by 10. Okay, so 20 divided by 10. So what you'll be getting, so when you are doing 20 divided by 10, the quotient will be 2 and remainder will be 0, right? So 2.0, right? 2.0. So this is quotient. Okay, when you are doing division, you will get the output as quotient. So division outputs quotient. And coming to the case of next one, which is modulus. Okay, modulus. So let's say when you are doing print, let's say 22, I'll do 22 percentile by 10. Okay, 22 percentile by 10. So this is the modulus symbol. Okay, percentage is the modulus symbol. So when you do this one, what you will get is you will get the remainder as the output. Okay, execute this. So when you are doing this, so normally 22 divided by 10, so 10 to the 20. Okay, remaining 2 will be your output. That's what the output of modulus. Okay, so 22 percentile by 10. So this one, so modulus gives you output as remainder. Okay, it's normal division only. So when you are doing normal division, so normal division quotient, and for modulus, it will give the remainder. Okay, that's it. And coming to the case of exponent, so exponent is power basically. So you know something like this, right? So 2 into 2, which is 2 square, right? And 3 into 3, 3 square. But if you want to do 3 power of 4, okay, 3 power of 5, so 3 into 3, 3 into 3 into 3 into 3 into like that you have to do, right? So normally 3 into 3, fine, this is a square actually, 3 square. But if you want to do multiply, okay, if you want to do multiply more times, like 3 times of 10 like that, or 3 times of 20, or 3 times of 5, so always you have to put 2 stars for power. Okay, 3 double star, let's say 4. Basically the meaning of this is nothing but 3 into 3 into 3 into 3. This is what the mean, 3 double star of 4. Okay, 3 double star of 4. Execute it. So we'll get it like this. Or so let's try one more thing. Of course sometimes this works and sometimes this won't. So okay, this is actually basically okay. There are some other programming language that works, but Python does not. Fine, leave it. So 3 double star 4 is basically 3 into 3 into 3 into 3. So 3 power of 4. Okay. So similarly, like let's say, so 56 double star 21. Okay, so big that number. Okay, 56 times 21. So 56 times 56 times, I mean 56 multiplied, power 21. Okay, so you're getting very big number. Okay, so like that you can do any number. Okay, so that's exponent or power. Okay, exponent or power. And the next thing is floor division. Floor division. So normal division is basically giving you divided by symbol. Okay, 20 divided by 10. Okay, that's normal division where it gives quotient. Okay, so say for example, this also gives a quotient. Okay, this also gives you the quotient, but it will round your number. Okay, so above we have seen, so 20, sorry, I'll do 21. Okay, 21 divided by 10. So normally 21 divided by 10. So generally what will be the quotient? So something like 1.1 something, sorry, 2.1 something like that it will be, right? So because when you do the remainder, 10 to the 20 and 1 will be the remainder, you will put a dot and 0, and then 1 you'll write. So 10, 10 and 10 it will go, you'll get a remainder of 0, right? So that will be, the quotient will be 1.1. Okay, generally the quotient for this is 2.1. Okay, so 2 times it will be divided, and then 1 will be remaining, and you'll put a dot so that 0 will be added, and then you'll divide by 1. Okay, so 10 into 2.1 is it, directly we can say 10 into 2.1 is 21. Okay, so that's the question. So now if I do floor division, so this is what the division output. But coming to the case of floor division, print 21 double slash 10. So this symbol, okay, when you are putting 2 times slash, that is a floor. That is the meaning of floor division. Okay, execute it. It will round off to the integer. Okay, it will round off to 2. That's it. Okay, that is what the meaning. So let's do one more thing. So instead of 21, I'll put 28 now. Okay, so even it is near to 2.8. Okay, so normal division when we do, we'll get 2.8, right? 28 divided by 10, 2.8. So even though if we do floor division, so it will round off to the lowest number only. Okay, lowest number only. Okay, or else say for example, print 28 divided by 10. Okay, so for this one, let's say I'll remove this print. So 28 divided by 10, 2.8. So for this one, I'll just put int. I'll apply integer, int of 28 divided by 10. So this also gives the same thing. So when I'm applying integer, that means, so previously it is float. 2.8 is float. Okay, decimal point. So if you want to convert this into integer, so you can apply int, so that it will round off to this left hand side number. Whatever the number is there, it will round it off to that. Okay, it will be removing the right side part. Okay, and it will just make it left hand side. So floor division for a decimal or an integer for a decimal, both are same. I mean, it will give you the same output. Okay, that's what happens. Okay, yeah. Any doubts till this point? Yeah. Okay, fine. Fine then. So I'll move on to the next topic. So you can stop me anywhere, guys. Okay, if you have any doubt, you can stop me anywhere. So next one is comparison. Comparison operators. Okay, comparison operators. So in comparison, we have multiple things again. Equal. Okay, equal to. So not equal to. Okay, and we have greater than, and we have less than. Okay, and then we have greater than or equal to, greater than or equal to, and less than or equal to. Okay, so these are all the operators that we have in the comparison. Okay, so I'll write each symbol also. So equal to generally denotes like this, sorry, like this. Okay, and not equal to will be an exclamatory mark followed by is equal to, so not equal to, and greater than, and less than. Okay, and then greater than or equal to, and then less than or equal to. Okay, like this. So this is how the comparison operators are there. Okay, so we can apply that for any numbers. Okay, so if we want, so above we have A20 and B10, right? So B10, so we can apply the same thing. So we'll see what will be the output. Okay, so A double equal to B. So if both are equal, then then the output will be true. Otherwise, it will be false. Okay, otherwise it will be false. So I'll write in a print statement. Okay, so print. So I'll write something like this: A is equal to B. I'll put a comma here. Okay, I'll put a comma. So A is equal to B, false. Okay, both are false, obviously, because 20 is not equal to 10, right? So I'll change the operator now. I'll put not equal to and not equal to. Okay, so A not equal to B. Okay, A not equal to B. Obviously, both are not equal. 20 not equal to 10. So obviously, your output is true. Okay, we are comparing. Okay, we are comparing two things. Okay, it's a condition. Okay, and coming to the next one. So greater than. Okay, so let's use greater than symbol. Then here also greater than symbol. Okay, so A greater than B. So 20 is greater than 10. So obviously it is true. And then next thing will be less than operator. And let's use less than here. So A less than B, false. Obviously 20 less than 10 is obviously false, right? So that's how it is. And then coming to next one, A greater than or equal to. Okay, so A greater than or equal to, obviously it is fine because 20 is greater than or equal to, so 10, so 20 is obviously greater, so that's why it will be true. And then last one, A less than or equal to, so less than or equal to, so true, sorry, false. 20 obviously is not less than 10 and it is not equal to 10, so that's why it is false. Okay, fine. So these are all the comparison operators. So these are very easy, right? So normally we can simply do it easily. Okay, let's do the next one. Coming to the next one, assignment operators. Okay, assignment operators. So coming to the case of assignment operators, there are again multiple assignment operators that we have. Okay. So the first one is equal to. Okay, just simple is equal to. That means, say if I am saying a is equal to 10, that is normal assignment. We are creating a variable. Okay, normal assignment. But there are other one, something like plus is equal to. That means addition. Okay, addition equal to. This is called increment operator. Okay, increment operator. Okay, so we call it as addition assignment. Okay, addition assignment. It looks something like this. Plus is equal to. Okay, and then next one is subtraction assignment. Okay, that means minus is equal to. Okay, and then division assignment, which is slash is equal to, and then we have remainder assignment, which is modulus is equal to, and then we have exponent assignment, so which is power. Okay, is equal to, and then finally we have floor division assignment. Okay, so that will be something like this. Okay, assignment operator. Okay, normal assignment, that is normal assignment. So let's do one thing. So I'll just assign some c is equals to 100. Okay, so this is normal assignment operator. Okay, normal assignment operator. So we are doing it daily, so not an issue with that. And coming to the next one, addition assignment. Okay, addition assignment. So normally when we are doing, let's say some d is equal to a plus b. So when I'm printing d, you're getting a value 30. Okay, you're getting a value 30. So assignment operators will be a different case. Okay, so let's say you are adding some value to a. Okay, say for example a plus 5. Okay, you wanted to say a plus 5, so which is 25. So a is 10, so 10 plus, sorry, a is 20, so 20 plus 5, 25. So but you wanted to store this same thing in a. Okay, so what you will do generally, so a is equals to a plus 5, right? So a is equal to a plus 5. This is how you write. Okay, a is equal to a plus 5, like this you will be writing. So what we can do is this we can be simplify. Okay, this we can simplify. Okay, stating so a plus is equal to 5. The meaning of this is equal to this. Okay, so this is simply nothing but a is equal to a plus 5 only. Okay, so we are simplifying our addition operation. Okay, we are simplifying our addition operation. If you want to add a number to the same operator and you want to store same variable and you want to store in the same variable, then assignment operators will be better. Okay, so now if I add it and execute it, so it is 25. It is still 25 only. Okay, it is still 25. So like this you can add and you can print it. Okay, like this you can add and you can print out your value. Okay, so coming to the next thing, multiplication operator. So multiplication assignment. Okay, so this one also same thing. So let's say if I do a is equal to a into 5, something like this. Okay, so normally a into 5, which is 25 5s are 125. Okay, so if I want to store it, so I can do a into is equal to, okay, 5, which is similar to a is equal to a into 5. Okay, so we are doing this as multiplication assignment. Okay, multiplication assignment, so you can print it. So the value is same. Okay, like a into 5, this is also same. So the same thing applies for division, remainder. Okay, so a divided is equal to 5. Okay, and execute a. Now again 125, it was multiplied previously and we got 125. Now we are dividing by 5, so now we got back 125. Okay, and then coming to the next one, a modulus is equal to 3. So that means a modulus 3, okay, which is 25. Okay, when you do the division, a divided by 25 divided by 3, okay, what you'll get, so something like 3 3 8 are 24, so one will be remaining, so 8.33, something like that you'll get. So now when you are doing modulus, okay, you'll be getting the uh, the remainder, right? So execute a and you'll see 1, okay, because 24, 3 8s are 24, 24 was gone from 25, so 1 is remaining, so 1 is the output. So that's what the remainder directly. Now a is having 1, okay, a is just having 1, okay, and now let's do the floor division. A floor division, okay, so I'll do something like, say for example, or sorry, between power is there, sorry, right, power exponent, okay, power is equal to some 4, okay, a will be 1 only, so whatever the power I do, it will be the same. And let's do the floor division, so it will be, so let's say I'll divide it by 4, okay, so this is basically a is equal to a floor of 5, like this, okay. So floor division, so 1 divided by 5, which is 0.2, so we'll be getting the left hand side value only, so that's why we got 0.0, okay, so that's why we got it. So these are what these are what the assignment operators, okay, assignment operators. Understood? Any doubts on this one, anyone? Okay, fine. So coming to the next one, bitwise operators. Bitwise operators. Okay. So coming to the bitwise operators, we have first let me do logical operators. Okay. Logical operators, we have and or and not. Okay, and or and not. So I don't know how many of you guys remember truth tables generally. So we have something like this called, let's say, true and true is like true, okay, true and false is what, guys, it's false, okay, false and true, it will be false, and false and false will be false. So this is a truth table, okay, like this we can apply in Python also, okay, not only in Python, in all the programming languages this is applied, okay, true and false, true and true. So and operator, okay, this is the logical and operator that we are using, okay. So based on that you're getting, so like let's say true and false, so you'll be directly getting the output as false, okay. Now let's do one more thing, 1 and 0, so obviously 0, because 1 is representing true, okay, 0 is representing false. In programming 1 is always true, 0 is always false, okay, 1 is always true, 0 is always false, okay. And coming to the case of and operator, and coming to the case of or operator, so in or operator, so it will be true, or true will always be true, and true or false will always be true, and false or true will always be true, and false or false only this case will be false. Okay, that's how it works. Okay, so let's take our example. So true or, so directly can take, sorry, or false. Okay, so directly you'll get true. True or false, obviously true. And then you can do 1 or 0, obviously you'll get 1. Okay, so 1 is true and 0 is false, always you can consider like that. Okay, so these are all the values. Okay, like this you can do. And coming to the next one, not operator. Not operator means, so if you apply not true means you will get false, and not false means you get true. Okay, not 1 means false, because not 1 is always, 1 is true, so not true, which is false. So not 0 is true. Okay, not 0 is nothing but not false. Okay, like that. This is not operator. So not is just going to do the opposite of what you give. Okay, not true is false, not false is true, like that. Okay, so that's how it is. Okay, so these are logical operators. Okay, and or and not. Okay, and or not. And coming to the next one, bitwise operators. So bitwise operators, and in bitwise operators we have same and or not. Okay, and or XOR we'll have. So we'll have binary and binary or, okay, and binary XOR. Okay, binary XOR. So in logical operators you will also have XOR also. Okay, normally. So you can do this XOR calculation also, but I'll just give you a small glimpse. Okay, what you can do. Okay, what you can do about this. So coming to case of, so here you have to think about this one, binary. Okay, when I'm saying binary, okay, so whatever your values are there, so that will be converted into binary format. Okay, those can be converted into binary format. So here I can take some examples. Okay, I can take some examples. Okay, uh, I would like to give you some example. Say, mm, so this one obviously directly I think I have to give some numbers, but let me see. Say, let's say I'll take some. I already have a0. I'll say a20 and b is equal to 10. Okay, a20 b10. So if I do a binary b, so it's actually like you have to convert the values of a into a binary format. So generally binary format looks something like this: 0 0 0 1 1 0 0, something like this. Okay, so it will be something like that. So I'm exactly not sure how how I can display you that. Okay, so that actually have to be converted into the binary format. So it actually looks like this. Say for example, if I say 0 0 0 0 0 8 zeros. Okay, so each value here represents, so this one is 2 power of 0, something like that. Okay, 2 power of 0, the first one, and this one will be 2 power of, sorry, power. Okay, 2 power of 0. So this 0 will be like that. Okay, and this 0 will be something like this. So this is the power values. Okay, this is the power values. Okay, I'm putting. So this third position will be 2 power of 2. Okay, 2 power of 2, and this fourth position will be 2 power of 3, like that. So if you are coming to the case of 20, okay, coming to the case of 20, like how can we do power and we can convert? Okay, so say for example, so maximum power in 20 that we can do is 2 power of 4, right? So 2 power of 4, okay, which is 16, and then remaining we have 4. Okay, so sorry, 2 power of 4 is 16, 2 power of 5 32, right? So 2 power of 4 we can do. Okay, 2 power of 4 we can do. So, and the other thing is, like if we do the remaining 4, what will be the remaining 4 value? That is 2 power of 2. Okay, that is 2 power of 2, which is 2 power of 2, which is 4. Like this if we do, the addition happens. Okay, 2 power of 4, which is 16, plus 2 power of 2, which is 4, 20 will get. Okay, so for that case, how I can write the binary format is, so 0 0 0 0, and coming to the next thing, 2 power of 0, 2 power of 1 I can give at 2 power of 2. Okay, 2 power of 2, so this one I can give 1. Okay, 0 1 0 0. So this is how I can write the binary format, because you can see this particular, the first one is 2 power of 0. Okay, second one is 2 power of 1, and third one is 2 power of 2, which is this value. Okay, 2 power of 2, and then this one is 2 power of 4. Okay, that is 2 power of 4. So like that you can convert. Okay, like that you can convert. I hope you guys understood this. Any doubts in this one? Is it confusing how to convert? Of course, this is actually 8th class or 9th class math. To convert the data into binary, actually. Okay, no one responding, no one understood, or what? Or you guys understood? Okay, guys, please respond. Okay, so don't be idle. Okay, I just wanted to see whether you guys are listening or not, because there is no point, right? So if you are not responding, please. Okay, yeah. So coming to the case of A and B. So now this one I can do. So coming to the conversion of B. So what I can do is 2 power of 3, which is 8, plus 2 power of 1. Okay, which is 2 cube 8, and 2 power of 1 is 2, so which will be 10, right? So for A I can write like this. So 0 0 0 1 0 1 0 0. Okay, and coming to the case of B, so 0 0 0 0, and coming to here, 2 power of 3 I can write 1, and 2 power of 2 is 0, and 2 power of 1 and 0. Okay, 2 power of 1 and 0. So now if you do the AND operation here, okay, if you do the AND operation here, so start away from starting onward, 0 and 0. Okay, so we are doing the AND operation only, but here we are doing the binary AND. So 0 and 0, that will be, so I'll do here. So coming to the first one, 0 and 0 0, 0 and 1 0, right? 0 and 1 0. So 1 and 0 again 0, and 0 and 1 again 0, right? And 1 and 0 0. So remaining all obviously zeros, 0 0 0, right? So you can do the AND operation. So the final answer is 0. Okay, the final answer is 0. Okay, final answer is 0. That's what we got. Okay, that's what we got. So That's why we got, when we are doing A and B, you can see the symbol. So this and, if I am writing, so that is binary and. Okay, that is binary and. So if I do A or B, okay, if I do A or B is written like this, A or B. So this is 30. So let's see why 30 is coming. Okay, let's see why 30 is coming. So coming to this case, 0 or 0 0, obviously 0 or 1 is 1. Okay, 0 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1, and 1 or 0 is 1. So this means, okay, this means here we have 1, so that is 2 power of 1, and this one we have 1, that is 2 power of 2, and this one is 2 power of 3, and this one is 2 power of 4. So which is 2 power, so 2 power 4, which is 16, right, plus 2 power 3, which is 8, so 24, and 2 square, which is 4, 28, and then finally 2 power 1, so finally 30. So that's why A or B we are getting the value 30. Okay, A or B we are getting the value 30. Okay, fine. Coming to the next case, A to B. Okay, A to, when A, we can consider this as cap, okay, or XOR. Basically this is XOR. Okay, so XOR, okay, XOR. So executed. So this also we are getting the same thing, because binary XOR or so binary are mostly both are similar. So what it does is it sets each bit to 1. So if only one of the two bits is 1, so that means if both are false, then only false, otherwise both are, I mean, true simply. Okay, that's why it will be true. So A XOR and so OR, mostly these will be similar. Okay, mostly these will be similar. Okay, so coming to the next one. So these are the bitwise operators. Okay, so any more that you guys want to ask questions or anything here? No questions, anyone? Okay, fine then. So we have completed the bitwise operators, and coming to the last one, last pattern, we have membership operators. So membership operators. Okay, so membership operators, we have only two things. One is in, and the other one is not in. Okay, in and not in. So say for example, you have a list. A is equals to I'll give something else. X is equals to 10, 20, 30, 40, 50. Okay, and I'll have yeah, this is enough. So I'll say, what is A? A is 20. So say for example, A in X, true, because A is actually 20. So 20 is in the list, X list. So that's why it is giving true. So now I'll give something else. Say for example 100. 100 in X. So obviously, sorry, 200. So 200 in X. 200 is not there. Okay, 200 is not there in the list. So that's why it is giving false. Okay. And same thing I'll do. So 50 not in X. Actually 50 is there. Okay. Actually 50 is there in X. So that's why it is giving false when I'm doing not in. 50 is not in X. So I'm just asking, 50 is not in X. So obviously it is there. So that's why we are returning false. Okay. And then let's give something else. 100 not in X. So 100 not in X. Yes, 100 is not there. Okay. 100 is not there. So this is membership operators. Okay. So just checking, okay, just checking in and not in, so whether it is in, whether it is not in, like that. Okay, and then coming to the last one, identity. Identity. Identity operators. Identity operators. Okay, so coming to the case of identity operators, also we have only two things. One is and one is not. Okay, is and is not. Okay, so is and is not are going to evaluate whether, so say for example if you are assigning two things, okay, say you have a is equals to 20 and b is equals to 20. So now if I say a is b, true. Okay, a is b, true. So now let's do one more thing. C is equals to b. Now if I do a is c, true. So here what happening is, so both are obviously same. It is similar like double equal to, okay, double equal to and all. So for every assignment operator, so for every assignment what happens is like there will be an id assigned to it. Okay, so whatever the variables on the either side of the operator so have the same object, then obviously it is true. So instead of is equal to, I mean double equal to, so we can use is operator. Okay, otherwise is not. Okay, otherwise is not. So if I say a is not c, okay, and a is not x, obviously this will be true because a is not equal to the list x has a list of values. A is not c, a and c both have same values, so that's why it is giving false. Okay, so like this you can do. Okay, so these are all the operators that we have in Python. Okay, and so there are some other maybe, and like if you go in depth, well there will be a lot, but these are the most commonly used operators that we have in Python. Okay, so any doubts, anyone to this part?